Welcome back to Mr. Hassan's Maths channel. I'm now answering question number 11 from the June 2017 C34 Core Mathematics C34 International A-Level Edexcel paper, which relates now to P3, this particular question here. And we have a equation y equals 2x squared minus 3 in brackets times the tan of a half x, and x is between 0 and pi. We want to find the exact value of x when y equals 0. So when y equals 0, we end up with 2x squared minus 3 times the tan of a half of x equals 0. So we have a product of two factors equals 0. So either one of them is 0 or the other one is 0. So either 2x squared minus 3 is 0 or the tan of a half of x equals 0. Now if I want to solve this equation, for both of them, in fact, my limits of x must be between 0 and pi. So for this tan half x, let's do this one first. You'll have x squared is equal to 3 over 2. So x is equal to the square root of 3 over 2, positive or negative. However, we can't take the negative one, all right, because our limits are starting x as from 0 up to pi. And is root 3 over 2 within the limits of pi? Let's see. Root 3 over 2. I think it is, because pi goes up to 3.14. This is 3.142, so on. So if we take our calculator and we do pi divided by 2, okay, that gives us, sorry, not pi divided by 2, root 3 divided by 2. Root 3 divided by 2. That gives us a value which is less than 3.14, of course, so that's fine. So this is our solution. Now it says the exact value. That means that this won't give us any solutions. If we check that, we can see that if I want to solve this equation, I've got to change this to make it match what we have inside the angle here. So I'm going to take this, I'll make this into a half x. So this is a half of 0, which is still 0, and this is a half of pi, which is pi over 2. Now, does the tan curve ever hit 0 between these values? No, it doesn't, because we know that the tan curve, okay, if I solve this equation, inverse tan of 0, I'm going to get a half x equals 0, and the next time when the tan curve hits 0 is at pi. Now that's outside of my range, because I can only go up to pi over t, because the tan curve looks something like this. That's 90 degrees. The next time it hits 0 at 0 and at pi. Okay, now I can't include 0 because it's not in the range, because it says x is greater than 0, so I can't include 0, and I can't include pi because it's outside of my range. So there's no solution in our, from what we're given here for this, so this is the only solution. So we can say x equals root 3 over 2. That's our only solution to this. That's why it says exact value of x. Okay, so just a little explanation why this doesn't give any solutions, and we only have one out of these two solutions for this. Okay, then it says, given that dy dx is equal to 0 when x equals alpha, show that 2 alpha squared minus 3 plus 4 alpha times sine alpha equals 0. So we got to start off, I guess, by finding dy dx. Okay, so we'll start off with our equation, which is this. Now, what we can say from this is that this is a product of two separate functions. So if I want to find dy dx, I've got to use the product rule. So I'm going to call one of them u and the other one v. So our u is 2x squared minus 3, and our v is the tangent of a half of x. So u dash is going to be 4x, and v dash, well, if you differentiate tan of something, you get secant squared of the same thing. So you're going to get secant squared of a half of x. But then you have to multiply by the differential of what's inside the function, so I have to multiply that by a half. All right, that's using the chain rule. So here we're going to find dy dx using the product rule. So dy dx equals, so you're going to multiply these two together. So 4x times the tan of a half x plus multiplying these two together, you have 2x squared minus 3 times a half times, I don't have to put that in a bracket, do I? So I'll put the half outside here. So it's a half times secant squared of a half x. Okay, most people actually do it the other way around. They do this times this plus that times that. I like to go from there to there because for the quotient rule, you have to go is this times this minus that times that. So I like to go the same way, start with the same thing first, because it just saves me confusion when I'm doing the quotient rule as well. Anyway, so now in this case here, we now need to make this look like that. How on earth is that going to happen? Well, the first thing is, it says we know that dy dx equals 0 when x equals alpha. So I guess we can say, let's replace x equals x with alpha and dy dx with 0. So we'll have 4 alpha times the tan of a half of alpha plus a half times 2 times alpha squared minus 3 times the secant squared of a half alpha. Okay, so that's one thing that we can go. Now this is equal to 0. When x equals alpha, this is equal to 0. dy dx is equal to 0. So this is dy dx. Put alpha in there, it's equal to 0. Now how on earth is that going to turn to this? Now one of the things I notice is that you have sine. And the other thing I notice is that this is sine alpha, and all these angles are half angles. So in my mind, I'm thinking of sine 2a equals 2 sine a cosine a, and also, well, that's the only one because we've got sine theta. So that's in my mind now. I'm thinking about double angles and half angles. Now, how on earth am I going to get sine a cosine a, or sine a half theta? If I think of this as a half theta, this will be like 2 sine theta over 2 cosine theta over 2, and that will be the same as sine of theta. That's how I'd get sine theta, because these angles are half that. See, these are half of those. So that's how I'm thinking. I'm thinking if I end up with sine theta over 2 cosine theta over 2, I can make something to sine theta. So the only way I can think of is let's change tan theta into sine theta, or tan half theta into sine half theta over cosine of half theta. Use the identity that we know, that the tan of an angle is equal to the sine of the same angle over the cosine of the same angle. So I have here 4 alpha, and I'll write this as sine of a half alpha over cosine of a half alpha plus, and this is 1 over 2. So I'll write this as 2 alpha squared minus 3. Now what I'm going to do is I'm going to write this as its reciprocal. The sec squared of a half alpha will be the same as 1 over cosine squared of a half alpha, because secant is the reciprocal of cosine. So I can write this as 2, because we've got 2 here, and that will be cosine squared of a half alpha, and that equal to 0. Now, it's looking a bit more promising. What I can do is I can make these into equivalent fractions. If I make these into equivalent fractions, I can add these two together. So I can make this denominator into 2 cosine squared of half theta. If I multiply both the top and bottom of this by 2 cosine a half alpha. 2 cosine a half alpha. If I multiply both top and bottom of these by that, I'll end up with something like that. So I have 8 alpha times sine a half alpha times cosine a half alpha. Now it's kind of looking promising. It's looking like I mentioned up here. I can see something like that here forming. Okay, and that's over cosine squared a half alpha plus, and this is as it is, we don't need to change this, 2 alpha squared minus 3 over 2 cosine squared a half alpha equals 0. Now, what I can do here next is I can, there's a 2 here, by the way. I had to multiply this by 2. So there's going to be a 2 here as well. Forgot that. Now I can make this under one denominator, which is 2 cosine squared. I'll write it as alpha over 2 now instead of half alpha, same thing. And this is going to be 8 alpha sine of alpha over 2 times cosine of alpha over 2 plus 2 alpha squared minus 3 equals 0. I can multiply both sides by 2 cosine squared alpha over 2 in order to get rid of this denominator. And then I'm left with 8 alpha sine alpha over 2 times cosine alpha over 2 plus 2 alpha squared minus 3 equals 0. So I'm almost there now. I'm almost there. I have to show it becomes this. So I've got my minus 3. I've got my 2 alpha squared. So I've got 2 alpha squared minus 3. So I'm almost there. It's just this part here. I have to try to now make this part as I want it. And I think it's exactly how we want it to be. Because remember, our identity is that the sine of 2a is 2 times the sine of a times the cosine of a. Now, if I make this the sine of, I can write this as 2 of sine of alpha over 2 times cosine alpha over 2, then this will become the sine of alpha. Because these angles, this is double those angles, so this is double those angles. So I can replace 2 sine alpha over 2 times cosine alpha over 2 with sine alpha. Okay, so if I take here 4, then I'll have 2. If I take out 4 alpha, just so I can leave 2 in here. So 4 alpha, and then here I'll have 2 sine alpha over 2 cosine alpha over 2 plus 2 alpha squared minus 3 equals 0. This now I can replace this with sine alpha. Okay, using the double angle formula for sine. So I have 4 alpha times sine alpha plus 2 alpha squared minus 3 equals 0. And that's exactly what we have to show. 4 alpha times sine alpha plus 2 alpha squared minus 3. So it's exactly the same thing. I'll just write it in the form they want it in terms of writing this first. 2 alpha squared minus 3 plus 4 alpha sine alpha equals 0. Okay, exactly how they want us to write it. And we have shown this as required in the question. Now, that was a bit of a tough one. I don't know how many people actually got there in the real exam, but that's a pretty tough one there. And what we had to do is at this stage, it's like, how on earth is this going to become that? There's no way to think about it. But the clue was that this is a half angle. This is double that angle. So the clue is, or the key is, using the double angle formula for sine. How am I going to end up with sine? Well, the only way to end up with sine is if you do sine of something over cosine. Tan is sine over cosine of something, right? So we did that, and then we thought, okay, let's write this as its reciprocal, and then when we put them together as one fraction, everything worked out. Okay, because we have to multiply both sides by this denominator anyway. If this equals 0, if the gradient equals 0, then it's the numerator that has to be 0, right? The change in y has to be 0, so that's the change in y. That represents the change in y, so that's 0. And then it worked out. Okay, so it's a bit of a difficult one, but we did it in the end. Is that part B? Part C? Yes, part C. Now you have the iterative formula. So it's a bit of a long question, this one. It says the iterative formula xn plus 1 equals 3 over 2 xn plus 4 sine xn can be used to find an approximation for alpha. Taking x1 equals 0.7, find values for x2 and x3. So basically, it's very simple. We have x1 equals 0.7. So what you should do is write x2 equals, and show how you get it by writing the numbers in. So 2 times 0.7 plus 4 times the sine of 0.7. Okay, and alpha is in radians. Okay. So we have to be in radian mode. So take my calculator. That's very important first to make sure we're in the calculator in radian mode. So shift menu, angle unit, radian. Okay, now, so x2 is going to be given by this. So you have 3 over. And what you should do here in this type of question, although it doesn't really matter, but it's better to do it this way, because there's only 2 we have to get to. But sometimes you got to find x3, x4, x5, and so on. Then, it's good for you to write the first number that you have to put in and press equals. That's now my answer stored in the calculator. So then when you set up the rest of them, you have 3 over 2. Don't put 0.7, put times answer. 2 times answer plus 4 times the sign of the answer. Okay, that basically puts the last value that was the answer back into this position here. So when I press equals, it will give me x2. So I can write this down and give each answer to 4 decimal places. So this is going to give me 0.754361. 0.754361. Let's just make sure that's correct. 754,361. So we can say therefore x2 is equal to 0.7544 to 4 decimal places. Okay, and then x3, all I have to do now, I don't have to write this out again. I can just press equals now, because this is now x2. To find x3, I have to replace the xn with x2. If I press equals, it's going to do that, because this, in this place, goes the last answer, which is x2. So I press equals again, it's going to automatically give me x3. So that gives me 0.706211, 0.706211, 0.706211. So x3 to 4 decimal places is 0.7062. So they ask us to just write those two down. That's fine. Then it says D, by choosing a suitable interval, show that alpha equals 0.7283 to 0.7283 to 4 decimal places. Okay, so now what we got to do is we got to go back to the original equation that we're solving. Okay, now the original equation we're solving is the equation, this equation here. This is the original equation that we're solving. Okay, this is what we're finding. This is the value of alpha for which dy dx equals 0. All right, so I'm going to take this part of the question. Okay, so this is the equation we're solving. So what we do first is we say, okay, let's call this f of x. F of x equals 2 alpha squared minus, or f of alpha we could say. Okay, 2 alpha squared minus 3 plus 4 alpha sine alpha equals 0. Okay, so now, not equals 0. We take that and make it f of alpha, not equal, forget the equal 0 part. This is the equation that we're trying to find the solution for this. So what we do is we want to show that alpha equals 0.7283 to 4 decimal places is the solution. Okay, that any number that rounds to this number, okay, when you round it to 4 decimal places, will be a solution to this equation. Okay, so what we do is we take a value which is, when you round it to 4 decimal places, take the lowest possible something can be and the highest possible value can be, such that it will round to 0.7283. Okay, so the lower bound of this will be 0.72825. If I round that to 4 decimal places, it's going to give me this value here. And the highest value it can be is 0.7283 and just below 835. So it's like from there up to everything just before that, like 83499. So we leave that as the upper bound, even though it doesn't include that. Now, any number, if the value of alpha lies anywhere between these two values, for example, if this crossed the axis here, equals 0 there, right, for the gradient function, all right, if it crossed there, okay, then if you round that value to 4 decimal places, it's going to round to this, because anything between these values, any number in between here, when you round it to 4 decimal places, will round to this. That's the lowest value. That when you round it to 4 decimal places gives you that number, and that's just after the highest value, right? So any root, if the root lies anywhere in this region here, it will round to this to 4 decimal places. So if I can show that the solution or the root lies between these two values, then I have proved that this is the root to 4 decimal places. Okay, so what I'm going to do is I'm going to put in the lower bound, which is 0.72825. I'm going to put this into this equation, so I'll have 2 times 0.72825 squared minus 3 plus 4 times 0.72825 times sine of 0.72825. Let me just get rid of this now. It's served its purpose to explain that. Okay. me write this a bit neater. I don't really have to write this down, but I'm just showing you how it works. So 0.72825. Okay, if I put those values in, we'll see what sign we get. Do we get positive or negative? So what I'm going to do in my calculator, I'm going to save this value 0.72825. I'm going to store this as A. I have to keep writing it down. 72825. Okay, so I'll have 2 times A squared, squared, minus 3 plus 4 times A, 4 times A, times sine of A, times sine of A. Okay, and that should give me an answer which is negative 5.143, or negative 5.14 times 10 to the power minus 4. So it's negative 5.14 times 10 to the power negative 4. And if I put 0.72835 in here, which is the upper bound, then I'm going to, get the same thing, 0.72835 squared minus 3 plus 4 times 0.72835 times the sine of 0.72835. If you didn't write this down, I'm sure it would be fine if you just put that in the answer. That should be fine. Okay, but just for the sake. So what I'm going to do now is I'll put 0.72835 and I'll store that as A again. Why? Because now that's my A. So if I go back now to this, it's going to take hopefully my new A value and put in there, and it does, and it gives you something positive. So now that's 2.6066 times 10 to the power minus 4, 2.6066. So 2.61 to 3SF, 2.61 times 10 to the power negative 4. All right, so we can see that when we put F 0.72825, that gave you a negative value, and F 0.72835 gave you a positive value. So basically, somewhere between those two values, it crosses the x-axis, and those two values will round to 0.7283. So we can say, as there is, and you have to mention this very carefully, even though it's worth 2 marks, as there is a change in sign. It doesn't say justify, but I'm going to justify, because normally it says justify that this is a root. So as there is a change in sign, and what we called f of theta is a continuous function, okay, therefore a root must lie somewhere, sorry about my bad handwriting, in the interval, and I can write it as 0.72825 and 0.72835. Therefore, we can say 0.72883 is a root to 4 decimal places. Okay, a little bit of an essay there at the end, but that's fine. So that's how you would choose a suitable interval, up and low bound of this value, show that there's a change in sign. Be very careful here, we have to use radians. I'm sure if you use degrees, you won't get the right answer. It won't give you a change in sign. Mention that there's a change in sign between those values, and it's a continuous function, therefore a root must lie somewhere between those values, and if they do lie between those two values, then of course anything between those two values will round to 0.7283 to 4 decimal places. So that's the reason why that is a root. So this is a very, very long question from beginning to end. Okay, lots of different things in this question happening, and it's a bit of a tough one, this part B especially. Okay, but yeah, anyway, we've got through it. And if you would like to see other questions from this particular paper, which is the June 2017 C34 paper, You can find those questions collected in this playlist over here. If you would like to see questions dealing with the topic of trig, identities, addition formulae, okay, was it trig identities? No, it was trig identities and differentiation, sorry. Okay, so basically differentiation of P3, you'll find it over here. Numerical methods and iteration, you can find the playlist for that over here, and you can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.